committee. Conocimos a Carlos. Okay. Estamos online.
Hi, hello, good morning for all. It is a pleasure and an honor for me to make this introduction by Dr. Abel Pérez González. Abel graduated in biological science in 1993 at the University of La Habana, Cuba, where later he obtained his master's degree in ecology and applied systematic in 1999 with Dr. Luis de Armas. In 2006, he obtained his doctorate at the Federal University of Rio de Janeiro, Brazil, with Dr. Adriano Brillante Curi. Later, between 2007 and 2008, he carried out a postdoctorate at the same university. Abel has been awarded with several grants, including the California Academy of Science and the Museum of Comparative Zoology at Harvard University. From 2018, he is an independent researcher at the Museo Argentino de Ciencias Naturales Bernardino Rivadavia. In addition to having published more than 70 scientific articles, Abel do a great work supervising students in Argentina, Brazil, Cuba, and Uruguay. It is for us, the committee organization of the 22nd International Congress of Aranology, and for me in particular, to receive Dr. Abel Pérez González to Uruguay, and in particular, today we'll be able to enjoy his plenary conference entitled Genetic Evolution in Opiniones and the Importance in the Systematic of Lineatories. Thank you very much.
Well, thank you very much, Carlos, for so nice introduction. I am very honored. First, I want to tell something. This is a very beautiful tie, which was drawn by hand by the dance mom. It is a very precious gift to me, and this is the perfect place and the perfect time for using. But for those to assist the dance presentation, he had another tie, okay? Then that means that this is not an independent acquisition of this character, but both terminals exhibit the character, okay? Well, first, I want to say that I am extremely honored to be here. I want to thank the organizing committee of the International Congress of Arachnology for this kind invitation. But I want to say that is, without doubt, one of the highest points in my scientific career. And I'm be honored to be here, and I'd be happy to be here as a Cuban. I'd be happy to be here as a Brazilian. I'd be happy to be here as Argentinian. And I am so happy to be here as a representative of the Latin American Arachnological School. Well, I will talk, before I talk, I want to say another thing. I want to express all my solidarity to all the fellows that have a hard times, have personal losses and economical losses in these last two very difficult, probably the most difficult years of the pandemic. All my solidarity for all of you. Well, now my talk will be about genital evolution in opiliones and its importance in the systematic of laniatories. I was so excited when the committee invited me that I select two subjects that could be do a conference for each one. Then I'm sorry if I put a lot of information and here fast. But I don't want to lose the opportunity to have all the Congress in the same room and talk about opinions. And for one time, everybody can listen to really good stuff.
Done?
Done?
No?
Okay. Okay. When I prepare this talk, I say, okay, we are living in a wonderful world, and until now, this is a world that has a very special condition of the material, is the light. And when I prepare this talk, oh, sorry. I said, okay, this part of this life have a sexual reproduction to try to perpetuate in the time. And thinking deeper, I think my talk is about movement, and I will try to explain this. One of the critical things in this part of the special reproduction of the life is the sperm transfer. And this is the critical part when you're talking about sexual reproduction. Then for my group, the terrestrial arachnida, not the aquatic one, we have several ways to sperm transfer. The most of them use spermatophore, but some others have a modified appendage like a chelicera in the solifugon, or have modified legs to transfer sperm, or modified pedipalps to transfer the sperm. But in all of these cases, the sperm has a step in the environment. That means it's a transference of the kind body, environment, body. But in harvestment, we have another different thing. We have a direct copulation with a direct body-to-body sperm transfer. And this is a characteristic of harvestmen and a few groups of acarid as well. And I think this is very important because produce a high assurance that the sperm will be reach the female body without loss in the middle of the environment. And this, I think, is an advantage. Well, not all the harvestmen have a body-to-body sperm transfer. The most basal one, Ciphotalmi, have a plesiomorphic condition, spermatophore, and produce an spermatophore. And this is the only case in opiliones. But the important thing here, and I think it's the difference with acari, is that at that point appears the penis and appears the possibility to do body-to-body transfer of sperm. And that means that we have 6,487 species with copulation in this group. This is an immense field for those that study sexual selection or reproduction and many fields. Right? And for me, it's a clear example that harvestment is a very unique order of arachnid where acquisition of a penis and the possibility to sperm body-to-body transfer was a novelty that guaranteed the success of the harvestment as a arachnid group in the earth. Then, the responsible to do this sperm transfer is an intromittent penis and a little more softer ovipositor. The penis is deposit the sperm inside the ovipositor, and inside the ovipositor you can find the seminal receptacles. The ovipositor have the mission to storage the sperm, fertilize the eggs, but also deposit the eggs in the substrate. His responsibility is beyond to the sperm transfer. Okay, we have a huge diversity of different kinds of ovipositor and penis in opiliones. In order to better understand, and this is very important, the evolution of opiliones, it is necessary to explore more in depth the morphology, the functional morphology, and try to have direct evidence from the study of genitalia in interaction. Because most part of the hypothesis about the functional morphology in the genitalia of opiliones were based in the assumption observed in the morphology of the genitals. But we have a very scarce or almost nothing information about what is the real functioning in when the genitalia were accomplished. Okay. One pioneer is in open our eyes about the importance of the genitalia to build a strong systematic system in opiliones is the Professor Joachim Martens. His pioneer work make a real change in the paradigm of a study of the opilion systematic genitalia, because before him, the study of the genitalia was almost descriptive, and they don't really use it for build a strong system in systematic and use it in taxonomy to define monophyletic groups. Well, this is the work that we need to do in front, because it's the best part that we don't know. And let's talk about a little bit about morphologies, because for you can understand my talk. In ovipositor morphology, we have a kind of ovipositor that is segmented and seems to be highly sensitive because have many sensilla and very many sensilla on the top. Okay, this is the common ovipositor. It's telescopable and very long. And the other kind of ovipositor have experimented a great shift in the morphology. They lost the segmentation and look at that they are less sensitive. And whereas in the tree of life of harvesting, we have Xiphophthalamus and Eunoid with this same segmented ovipositor, and these ovipositors have two long spermatheca, where the sperm are deposited, have this highly sensitive kind of sensilla, and you can see how they are telescopal. I mean, they have several muscles and very sclerotized plates here, and have a little bit reduction in the Eunoid, reduces the plate, but still have the muscle connected the segments. Okay. The big the first big shift in the morphology is become in this Eunoid, the system group of Eunoid, that this kind of not segmented ovipositor. There is a very dramatic change in the morphology here, and also appears multisacculate spermatheca. Okay? And this kind of less sensitive and not segmented ovipositor is maintaining in Laniatores, but in Laniatores appear the famous X-shaped vagina and radial spermatheca in the ovipositor. Then it's very important to understand the morphology of ovipositor because it's a neglected part or a neglected genitalia in harvestmen. They have a furca here, and they have a stretchable part or winker portion here, and they have two main lobes with a furcal growth and then a pseudo growth that make a false appearance of four lobes in some ovipositors in harvestmen. Why this is important? It's because you need to go to the study of fan morphology to really define properly the parts. This is an insidiatores and this is a grasatores, and both was described as ovipositor with four lobes. And this is not homologous because this is the part of the basal part of the ovipositor and they have only two lobes, and this division in four lobes occurs here in the furca and not at the base. Then when you say ovipositor with four lobes in one infraorder and in the order, you are not talking about homologous states. Okay, the internal receptacular in grasatores have the famous egg-shaped vagina, and this is how it looks like. Thank you very much, Stephanie, for the nice picture. And you have here a camera of the receptacular, and if you open one ovipositor, then you can see perfectly the four camera where the receptacles are located. And these four cameras together is responsible to have this X shape in the ovipositor receptacle area. And these straps here are the denticles that you see in the internal wall of the X-shaped vagina. Well, the morphology of the female ovipositor was highly neglected because everybody say, okay, this is to have a high stasis, this don't have a variation, and nobody uses it. But we are almost finished an atlas of the ovipositor X morphology, comparative atlas, and we have more than 500 images of same microscope. We have 97 plates ready, and we survey all the families of Laniatores, less two families, because it's hard. Every time appears new families in the systematic of Laniatores, and other are hard to find. But the good thing is that they are not so homogeneous. They have a lot of information there that we need to explore more in depth. Up to now, not for only just example, I have to see a very special morphology in one of the brand new families that we proposed, Belonicidae. And I happen to see that this white macrocita is probably characteristic of all Salmonixoidea, of course, with some reversals condition, but also the Chimulidae have a very special morphology. Then we have now a lot of information. We need to look for character, and we need to revise the utility of ovipositor to build a systematic system in opiniones. Okay, let's go to talk about a little bit of penile morphology. This is an schematic explanation for trying to topologically locate some of my terms that you understand when I talk. The penis is a long tube, chitinous tube, that we can divide it in two parts, the glans and the truncus. But the glands is one of the most difficult parts in the pineal harvestment morphology to define homology. It's really hard to do that across the groups, and sometimes the glands is congruent with the part distalis, but in other times the part distalis include also part of the truncus. Then I prefer to call that the pineal morphology in the harvestment have a truncus and a part distalis that could include the glands. This is an example from one biantid, African biantid. You see the pops. And with all of this in mind, you can do it a really deep study about the morphology of the genital, including the form of part distalis, form of part basali, and a deep study of the glands with an external capsula or an internal capsula, and try to characterize it as much you can, the morphology, for trying to see what happened with the morphology. Exists two different kinds of penis in opiliones, and this classification is referred how they are functioning or how they are moving the different component parts, the different sclerites. The plesiomorphic stage is a muscular, muscle tension principle of functioning muscular type of penis, and the derivative stage is a complete hydraulic, hemolymph pressure principle movement penis. This is pretty analogous with what happened in spiders that moved from one kind of muscular pedipalps, male pedipalps, to an hydraulic pedipalp. And we can see in the evolution of opiliones that the muscular penis appears here in eugnoid, in this noid, in insidiatores, and the big shift in the morphology in grassatores. The grassatores have the huge but the immense diversity of forms and movements into the genitalia of harvestment with a more high diversification of forms. Okay, well, I point here one thing that I think is very interesting and challenging. The major morphological shifts in penial and ovipositor morphology are not synchronized in harvestment. That means that, the big shift is the pass between spermatopositor to penis, and they don't have response in the ovipositor morphology. That means that the groups have the same ovipositor. The second is the pass from high sensitive and segmented ovipositor to non-segmented and less sensitive ovipositor, but don't have response in the penial morphology. We still have a muscular penis. The third one is not very big, but it could be important, is the presence of the sheep X vagina. Also don't have a response in penial morphology. And the last shift is the pass from muscular to hydraulic penis, and don't have response in the ovipositor morphology. That is very interesting, and many questions will be arise to try to explain why happened that. Now, the complexity in terms of the number of sclerites and diversification of movements happened here in the trianonicoidea harvestment. It happened here in muscular and as well in hydraulic penis. And in a real, a huge increase of number of sclerites and different type of movement. And I think maybe, I think that this is a difference with the spiders, because it seems like a huge diversity of movement in the spider genitalia. I don't mean complexity, I mean in type of movement, it's restricted more to the hydraulic part. But if we talk about movement, okay, the first movement that I want to talk is the movement of Raquel Werner, that she come from the Glauco Machado lab, and she movement to our lab in Argentina to receive a training in genital morphology, because she want to do her PhD in Germany with Dr. Bernard Huber, and she want to train him first to how she can do that, because Huber was not a specialist in harassment. And she arrived for my luck, she arrived to our lab, and we produced a very nice and broad of this paper, but we are very lucky to find this, because the first thing that I give to Rachel, okay, do you want to know how is the morphology of a male genital? Okay, let's go to redescribe this species, because we have a huge type series there, and was a species described by Elias Suarez, and redescribed very well by Emilio Mauri, and we have drawing of the body and drawing of the genitalia. Is a good thing for beginning. But what happened? Oh, I do the genitalia, Abel, I do the genitalia, but looks like a different species. I don't know, this is the drawing and this is the genitalia. What? It's impossible, because Mauri was a very good taxonomist. It's impossible that they have two different species in the type series. Well, this is not so impossible, but it's very hard. And I go and saw another harvestman, and what? Now I have the real species. What happened here? I was very confused at that time. I saw many things, many strange things. I saw this part is very different to this one, but this part is so similar between this, and this part is also in a different position, and the muscles, you see, is contracted. If you compare, this is here, but this is more down here. Okay, something happened with the muscles and the styles, I think. Okay, it's a very extensive. Let's go urgently to the same microscope, and we do it a deep study of the morphology of the genitalia of this species. And when we have the imaging from the scanning electron microscope, I say, okay, this is the internal wall. The capsule external was blended down, and this is the ventral plate that was dipped inside here. Then our hypothesis was, okay, this is a case of aversion, because this is the movement of the dorsal plate of the capsule externa, this is the movement of the capsule interna, this is the movement of the ventral plate, and this is the movement of the tension of the tendon. Wow. Okay, and I try to make one slide. I have, of course, no movement, but let's see if we can do that. Okay, that's what happened here. But the problem is the version of the internal capsula is a condition only for the hydraulic penis until that moment in harvestment. Then we have an analogous functioning in two different kinds of genitalia. We have everted movement, reversion movement, of course, in hydraulic genitalia, but we also have eversion movement in muscular genitalia. It's a case where the genitalia functioning in the same way, but it's a different way of to do that. an analogy. Okay, but what could be the role of a virtue in the harassment reproduction? I think it's the time to remind that harassment and spermatozoa are a flagellate and mobile. Okay, the sperm don't move it. And I put all the picture in scale, and we saw that the receptacle area is down in the bottom of the ovipositor, and I put the genitalia also in scale. And I saw that the measure of the capsule interna, when it's in rest, will be reached this depth. And when it's everted, the measure rear almost the area of the seminal receptacle. And I think that this is very important to deposit the sperm, the aflagellate, the mobile sperm, in the right place to guarantee that the sperm go into the seminal receptacle. Then, in this case, the size matter? Yes, the size matter in this case. In this case, sorry. Okay, and now after you discover that, then you see everywhere inside Rhinonike, of course. Then how I don't see that? It's like the bites of the sample that Peter gave you in the first day. How I don't see that? And William Porto, our postdoctoral researcher, studied many of these everted genitalia across all trinonychids, and we think now that this is the normal functioning of the trinonychid genitalia in all the family, or all the superfamily Trinonychidea. But sorry, Williams, the Earth discovered first. This is Maria Fernanda Cardoso, that is a Colombian artist. She was based in Australia. She loved doing art with the genitalia, and she loved the Rhinonachid genitalia, and did a very nice exposition, and she reproduced everted genitalia, non-inverted genitalia, everted genitalia, non-inverted genitalia, everted genitalia. This is the first case where the art go first than the science. Okay, let's go to continue about movement. Then this time, Raquel moved to Mexico, to the place of our friend Rogelio Macias Ordóñez, and she wanted to see or discover a very nice or easiest way to extract the genitalia without needed of cutting and make the sometimes hard dissection to extract the genitalia in opiliones. And I want to point that the genitalia of opiliones have, this is the penis, but this is the pregenital chamber. We also call it velum. And the velum is a very interesting structure. We detach the velum and don't care about this, but they deserve more research because it's a very interesting. They have muscular fiber, like in fruits, like this, and they are responsible for the protrusion out and in of the body of the harassment. And I try to see that probably this is the velum, and this is an everted genitalia. This is a, protruded genitalia. In blue is the penis, the par basalis of the penis, and this is more or less a working. Okay? Well, I suppose that, okay, when Raquel go to the house of Rogelio Macias Ordóñez, make a very hard field trip to the garden, and pick up some very nice Stenopsidae. I want to have Stenopsidae in my garden. I am so jealous. Well, and they test the equipment that they use to extract venom in scorpion, to try to see if they could avert the genitalia and don't need to do the dissection, no? And that was happened. Wow. Okay, that is a very new movement. They have a circular movement, and I mean, that don't mean that they do this during the copulation, okay? Because we don't see the genital interacting. The only thing that that means that the velum allow this kind of movement, okay? But if you have a radial receptacle in the genitalia, it's a nice thing to test, no? You need to thinking about. Probably not, but I don't know. It's a very interesting thing. Okay, back to our museum. The part 2 of the Raquel movement was very interesting because in the real deep desire of Raquel, she wanted to freezing Pérez in copula for the first time. And we need to think, we spent 2 seconds in think what is the most effective protocol to achieve this goal. We, for sure, have 2 seconds, and we have the perfect protocol. We designed the perfect protocol, and the perfect protocol was Raquel go to the buquebus and go to Uruguay and meet Carlos Toscano Gael. This is the right protocol, because he and his student developed a very nice model, and he reached it at the lab and studied the sexual component for many times with Pachyloides torelli. And if you will have a success, you will have a success with this research team. And of course, they prepare the arena. It's not an arena, but they make it. They make it. And after more than 250 years of the feed harassment description, we can see the first images of coupled genitalia in opiliones. That blew my mind, of course. But it was very important for us because this is the good opportunity, the best chance to prove or to test many of our hypotheses that we put in our chapter in 2010. One of my favorite works developed or invited by Rogelio, Glauco, and Jeff. I love it, this experience. And now we have to, but for doing that, we need to do another thing and design another protocol. And the protocol was invite Peter Micali and Gabriel Wu to try to put the coupled genitalia in a micro-CT to try to discover as much we can about this interaction. And wow, we have a success as well, okay? And we have a very nice images from saying we have a very nice reconstruction, but we have only one yet. Then the first thing that we can able to test is like the non-destructive analysis of the coupled genitalia of Pachyloides torelli revealed that the entire part distalis penetrate into the vagina during the mounting or during the copulation, supporting the hypothesis who defined the part distalis. as is the part that interact with the ovipositor as opposite to part basalis. Okay, wow, yes, we are right in our previous hypothesis. The part distalis, it's completely inside the ovipositor. The ovipositor peripheral sida, this is the peripheral sida of the ovipositor, are oriented out the side, surrounding the penis truncus. The sida are not blend or deformed and do not invaginate during the penis intromission. As the peripheral sida on the pulca do not blend to the inside, we refute our previous hypothesis, because we think that the sida come down and interact with some sensitive part of the penis. The other thing that we have the opportunity to prove it is that the ventral plate of the penis with its ornament, I mean the macrocida of the penis, seems to play an important role in the genital coupling, especially with regard to the anchorage system. In order to prevent the coupling of the genitals during the copulation, a solid anchorage system to be important, which can also provide a mechanical stability for a successful sperm deposition. That was, the imaging seems to be agreed with this previous hypothesis. And probably one of the most important discovery was that the part distalis does not reach further than or ever penetrate the egg-shaped region. This is in contrast to the previous hypothesis who postulate that the part distalis is responsible for opening the lumen of this egg-shaped vagina, and this doesn't happen. But let's to explore a little bit what is the shape, the egg vagina. What is this? Okay, I told you previously that this is the walls of the receptacle chambers, and when we saw when the genital is coping, when the genital is functioning, we don't see lumen here. That means that it was closed, perfectly closed. No any single lumen between the walls. I call like a Ziploc closet. Here is the smart closet. I agree with it. And I was so that is in all the deep of the wall of the genital chamber. They isolated the genital chamber, but I think, okay, they are discrete chambers or they allow to communicate between them. And also we can prove that because it was simple. This is the stylus, this is the receptacles, this is the sperm, and if they have communication, the closer receptacle to the stylus, this is the opening of ductus ejaculatorio where the sperm go out, the closer must be filled and the farther must be empty. And that was exactly what happened. It's filled, the next two on the next chamber is filled, and the farther is still not filled when Raquel frozen the harvestman. And was a clear idea that then the egg vagina is not a vagina, and is a multifunction conformation of the internal wall of the receptacle camera that allow, first, stop the penis intrusion. Second, receive all the sperm in a single penetration. Third, above the sperm presence beyond the seminal receptacle area, and maybe guarantee more female control over the sperm. That, in other words, means that these egg shapes make functionally that the four chambers and all the receptacles function like a single huge seminal receptacle in Laniatoris. Why the female could have any control? I think, what keeping this like this? And Martins gave a hint. This is incidadores, this is cyphophthalmi, this is eunoid, and you saw that in laniatores, the huge amount of circular muscles surrounded the seminal receptacle area. That means if this muscle was closed, then the walls could be closed as well. But if they do it stronger force, maybe the female can reject the sperm. Because we have this scanning electron microscope of one Asamide ovipositor that we're thinking, at the first time and we published it, we're thinking that this is a plug, but could be also a first sample that the female could reject the sperm storage in the sperm receptacles. This is just an open window, and much of research needs to be done in this line. Okay, we have also another thing. The ventral process was pointed as one of the structures capable to removing the sperm. Still, we don't find any direct evidence of this, but I found a very nice group of persons. I found a very motivated and efficient PhD student, Stefania Steinley. I found, well, everybody know Anita and how she represents as a women arachnologist, and David Guadebrecht from Córdoba, who kindly invited me to co-advise Stephanie in her PhD. And another movement, then Stefania moved to our lab, and she wanted to study the variability of the morphology of the genitalia, and she wanted to study the variability as well of these fields of the microseta, the call it microseta, and have a very well pattern studied by Adriano, different pattern across Onychopteria. And for 2 or 3 samples that we put in the same microscope, we found this. Wow. That means that field can remove sperm. This is a spermatozoa of Opeliones, and this is the sperm removed by the penis. Okay, this is a trial developed in virgin females. That means that this is their own sperm. I don't know if they use it for if they use it for removing sperm from other males. But the only thing that I know right now is that this structure can remove sperm. Okay, another open window with too much research to do. Okay, exists any other direct coupling data in the rest of the suborders? Only for eunoid, sorry. But from early, this is probably one of the most clever experiments doing. Jeff put a light, and we saw a copula by the transparency of the body of the animal. I artificially painted the ovipositor to better see that what happened, and this is what happened. This is a series of penetration of the penis in the body of the female, and we saw clearly the deformation of the ovipositor. And that was interpreted by Rogelio Macías Ordóñez like somehow seems like the tip of the penis is stuck in the tip of the ovipositor. We know by morphology that in 6 species of Neopilionidae, the length of the stylus corresponds exactly with the length of the sperm receptacle. Then that is a good hypothesis to work. But again, Rachel had success. Now in Germany, she moved again to Germany, she can freezing two couples of the most studied harvest in Europe, Arachium opilium, and she had partially success in freezing two couples. I want to remain that the simple genitalia in Ebloin has only this kind of movement. It's only like an erection, 90 degrees of the gland. And we have, I will show the result of the first pair. This is in green is the penis, in pink is the ovipositor. And we saw that the penis come inside the female in the rest position and deforming the furca and don't be able to go inside the ovipositor. The second pair have a little more success. Now we have that the penis have the erection movement and reach only the tip of the ovipositor. This is the two pairs that she reconstructed, and what we know, what we learn about this. Okay, the penis can move the gland when it's inside the female. That's a very interesting thing. The other thing is, without total expansion of the gland, the penis cannot penetrate the ovipositor. And the third thing is a completely expansion of the gland made possible the penetration through the furca, positioning the stylus close to the seminal receptacle opening. And I mean that this is for me, have a very interesting data for comportment study, because some comportment students could say that this is a successful copula when study the sexual comportment in eunoid, and must be very careful because a penetration don't guarantee that this is a successful deposition of a sperm in the sperm receptacle. Then this shows you an alarm for pay attention for production study, comportamental study in embryonic. Maybe some copula are not effective copula. Okay, all this information leave any importance in the systematic of opiniones? The thing that I want to talk here is that we have many layers of information, many sources of information. For example, we have the exomorphology, we have the genital morphology, we have the genetic data, pathology, development, etc. And only when we increase to use all these layers of information, we will have a perfect and complete picture of the animal that we study. And now we are in 2023, and we are almost 100 years of the most influential work for the study in Harvard, the Vida Nächte der Erde, right? Okay, do it by Karl Friedrich Weber. And Weber was the most influential opinionologist without doubt, and he built a system that in part is still used today. And they do this with only of the layers that I showed before. They all this only with exomorphology, and that could explain what happened here. It's with you who uses only this information in a typological way of thinking. You have that a group with one character could be a family, and the same group, morphology, similar group, without this character could be another family. And this have many implications for create an artificial system of classification, because you could create groups based in character that could be convergence or independent acquisition, and it's not a natural group. And also you create groups based in no synapomorphy or probably based in a plesiomorphic exomorphological conformation. And that's what happened, thinking in this way. Reber described into Phalangodidae, into one family, all of these taxons that are dispersed in all the tree of life of Grassatories. Then, for Reber, the concept of the real Phalangodidae is probably the concept of the old infraorder of Grassatories. Okay, that happened because they have only one layer. And that is what happened. I put only one example, family Stigmatidae. They recognize this like a subfamily of Phalangodidae because it's very different. But even like that, they create several monotypic genera. He was a splitter, and into Stigmatidae. But even if one part of the Opilionology say, no, it's not good, not exist so many monophyletic, monotypic genera, your system are wrong. Okay? As good night and good night, they go to the opposite part. They fused all the species in huge synonyms, and now the good family, the current concept of Stigmatidae was only single species that he said that was a very high variability, high variable species. And then that means that even if you have criticisms for one system of classification, if you are not agree with the system, if you don't change or don't increase the layers of information, the amount of different types of information, you probably will another defectus system as well. That was happened with the lumpen and splitter stage in Opilionology, in Opiliones taxonomy. One example is, for example, I only add a second layer to this system, the information of genital morphology and my PhD. I put all the genital morphology and will a phylogenetic analysis, and I recover a concept of Phalangodidae, or Stigmatidae, sorry, very different. Okay? But the thing that I want to point is even with that, we incorporate the third level of the third layer, that concept don't change. That means that I think that if we have genital morphology in the Reber system, we could be a rise to the omics era in better shape than we have now. Okay, probably like this, maybe. Okay, Professor Martins was essential for telling us that genital is important to define monophyletic groups. And many of us for years now feeling like this title of the paper that we have a pleasure to do with Prashant Sharma and Daniel Pro, like a morphological tricks and oh, blessed genitalia. But we must be careful with that, because it is not a universal panacea, and the blessed genitalia could be transformed into genitalia. And why I say that? Because, for example, I will pick up two examples from the work of William Porto. This is two monotypic genera, Valdivionex and Nahuelwoni, described by Emilio Mauri, and he paid attention to the genital morphology, they say, no, it's two different genital. They must be two different genera. And when we do the molecular phylogeny, they are sisters in the molecular phylogeny. Then they are having another thing. Why they genitalia driven or have a derivation of the morphology. And when you look the ovipositor, you have for the first time ovipositor with a sclerotized structure there. Well, my mind is growing again and make several hypotheses about how functioning like this. But again, the nature gave me a lesson. This is here another new species from the genera you see, from short to huge clasper in the female genitalia. This is completely new. And the nature gave me a lesson again, and we have the luck to have this animal. We found this animal in the collection with suspicion they have the male genitalia. With him is a couple genitalia of this group, and here we saw this structure, and that means that this structure is don't be in contact with the part distally of the penis, but it's in contact with the velum, and the velum contains the nuptial gift. And then probably the female play an active role in keeping or fighting for a nuptial gift in the interaction in this group. And probably this was the force that driven so different morphology or male genital morphology in this close related animals. And the other thing, and the last thing, is the hyperstellic genitalia. If I only genitalic taxonomies, I will describe this with probably in another family than this. And when we do it, the molecular, they are sister group as well. And when we saw where is a hyperstellic genitalia laniatoris, they occur in several parts of the tree. That means they are nice model to study what happened there, where the force that driven these so different genitalia. Probably these species have the most deepest seminal receptacle in all the order. Okay, for last thing, I want to ask permission to the organizing committee to pass some advices for young arachnologists that I take from my previous advisors or from one very close friend. All of them, they are arachnologists that leave their imprint in my work. Okay, the first advice is be detailed, exhaustively detailed, and very carefully with your observation, and pay attention to the minimal detail. I learned this from my basic degree, master degree advisor, Luis de Armas, from Cuba. The only advice is always try to see the big picture. And there is too much information in the bibliography. Read and find the hidden details. Don't write only the abstract. I learned this from Adriano Puri, that was my former advisor of the PhD and supervisor of doctoral study. The other thing that I learned is from my friend Gonzalo Glibec. Always be open to using new sources of information, new approach, and new methodology. The last advice I learned from my long-term friend and colleague, Martin Ramirez, have always a biological question and try to respond it. And my last advice is always test all the hypotheses, including yours. Don't feel bad or sad if one of yours is refuted. It is better to correct mistake than to perpetuate them. I want to thank first the organizing committee for the very kind invitation. invitation. I am truly honored. My agencies, local agencies, the foreign agencies and institutions, all the curators, my deep thanks to all the curators that believe in me and allowed to make the loan for more than 25 years. I want to thank all the colleagues where I discussed all of this in the time since a pretty long time ago when we were young folk, and the new ones that I will hope to belong many further discussion. I want to thank my current and my past students because they learning too much, they advising too much. It's a mutual construction. I think I learned about their question. Thank you too much for trying to test my hypothesis that made things a lot. I think it's essential. And I want to thank my Vermeer's team. Is probably the most best place and comfortable place in the world to make arachnology and cyanonology. And this is another lesson. It's really important to feel like a home in your lab. And I want to deeply thank the Opiniones research community because it's really collaborative. It's a very good community for research with so many collaborations, so many kind, open people, and that do the work much easier. Thank you very much. Muito obrigado. Muchas gracias.
Thank you, Abel. Excellent, excellent presentation. Thank you very much. Have time for questions?
Here we have one.
Great talk, Abel. My question is about the ovipositor. When you showed that picture with the segmented ovipositor, I'm just wondering, do you think there's any morphological similarity with how the tarsi and the tarsiers work? Are there any tendons in there, or is it all muscular? How does that work?
They have only muscle. They have only muscle connected. The segment, well, the walls of the H pseudo segmentation, and I think it is he is expanded by hemolymph, and the muscle recover the imbricated position of the ovipositor. Works like this. No tendon inside the ovipositor.
Cool. Thank you.
Do I speak? Yes.
Hello, Abel. How are you? I used to say to my students that organs are not created nor destroyed, but only transformed, except in the Cambrian explosion when everything goes crazy. What would be the homologous feature to the penis in opiliones, for example, in spiders, the tarsus, the pedipalp, so on and so forth?
The homologous region in the penis.
No. The whole structure, for example, in the spiders, the tarsus of the pedipalp is the copulatory organ. In Ricinurid, the third leg. In Solifuga, the thing of the calicary, okay? In opiliones, what would be the feature that transformed in the penis of the opiliones, or is completely another feature?
No, the copulatory organ is the penis, and the part distal is the part that goes inside the ovipositor. I mean, I think that I understand.
No, no, no.
Question, but
Okay, I will ask you later the question. Sorry, man.
okay.
We have one from here. I think I've responded to the previous question that the spermatopositor would be the sort of homologous structure because it's shared with some mites, but you know, in planetories, so many different movements occur as part of the externalization of the penis. I am more familiar with eupnoi, where it's a bit simpler. So my question was also about the ovipositor. To what degree does Laniatories have cuticularization of the ovipositor? Like the putative seminal receptacles, do they have any sclerotization inside?
Yes, the so-called sheath vagina is highly sclerotized structure inside the Laniatorius ovipositor, and that was one of the most nervous discovery in the coupling genitalia. They are opened when it's resting, but when it's go to do the copulation, they close it, and close it implicated so strong that you don't see any lumen between the walls of the camera, and that formed a very strong structure that don't allow to the penis go farther deep in the tract. They stop it, but they stop it there because there it's like I mean, okay, now we are open all the receptacle for you deposit the sperm. Then this structure allow that all the receptacles function like one receptacle, one single receptacle, but also prevent that any undesirable sperm go farther from that point. For that reason, I say that this is a multi-functional structure with several implications in the sexual reproduction in herpes.
Yeah.
Hi, Abel. You blowed my mind. Muchas gracias. Adriano created an scheme about the number of macrocytes these laniatories have in the penis. And the number 11 is, I don't remember exactly the number, but this number is very constant across different families. And we know that these genital characters evolve very fast. And even in closely related species in harvestment, this number is pretty constant. Do you know any idea why they are maintained in such a broad phylogenetic scale?
Well, Glauco, this number is very constant in Gonileptoidea only. Only in Gonileptoidea. I mean, Gonileptoidea is a special case where the genitalia is highly conservative and the external morphology is highly variable. And I mean, I think they are constant because they don't have too much pressure for change. This is enough for keep the genitalia inside the female and display a very comfortable anchorage to deposit the sperm. But if you go to Pelonicidae, you go to Pyramidopidae, you go to even salsa places, you can, in some parts, when the genital evolution become more stable, more static, you can try to select some homologies among the macrocyta. But others, it's like hundreds of macrocyta inside the same genitalia, and you cannot trace the homology there. I think it is a valuable result, but have utility, differential utility, depend of the group that you are studying. The thing that I think in Gonileptoidea, you have huge spine, but you have tiny spines, no? And my hypothesis is they are non-functional spine. Maybe in other group, this spine that needed more, attach more the genitalia inside the female, probably this rudimentary spine are become, or I sound like Lamar, sorry. Probably they have a very strong or extra anchorage macrociliary.
We have time for only one question that is here.
Abel, great talk. I was wondering in these species in which you show that the male removes sperm. I missed the part maybe in which you describe the female part, but I assume it's similar to what you said that he cannot reach the spermatozoa. So for removing sperm,
It's the same species.
okay, I missed that, sorry. That's why the female needs to take sperm out for him to remove it, or not. The female needs to take the sperm out of the spermatozoa to a place where the male is able to remove it. If not, it's impossible for him or not.
But if you have an over-secretion of a sperm, you can remove it, and the female can, if the female have the receptacle feel it, and the male still continue to drop a sperm in the lumen of the vagina, they can remove their own extra sperm as well.
Okay. Because I was thinking something like, donates, it happens something like that, in which the female needs to take out the sperm in order for the male to be able to remove that.
I mean, that could be happening. Well, see, that need to study more in depth. Could be that the female remove the sperm, and when the male go out, carry the sperm, or can mean that the male use a lot of sperm for plug, or that means they have a over sperm production to try to guarantee a complete field complete the seminal receptacle. Thank you, Abel. Congratulations. Now it's time into a little present.
Oh.
Remember that today we have the photo of the Congress.